Let me ask you something. When you talk to a voice AI, whether it's a customer support bot, an AI assistant, or a voice agent on your phone, it talks back almost instantly. No loading screen or no awkward pause, and it just responds, which just feels like magic. But here's the truth. It's not magic. It's a three-step system, running in the background, processing everything you say in milliseconds. And once you understand how it works, you'll never look at voice AI the same way again. In this video, we're breaking down the exact three systems powering every voice AI agent: speech-to-text, the LLM brain, and text-to-speech. Let's get into it. The moment you open your mouth, the first system kicks in: speech-to-text, or STT. Think of this as the AI's ears. Your voice is just raw audio, a waveform. STT converts that into text the AI can actually process. But here's what most people don't know. It doesn't wait for you to finish speaking. Modern STT uses something called partial transcription. It sends chunks of your words to the next layer even while you're mid-sentence. So by the time you've said, "Book me a table," the system has already started working on a response. The best models today, like DeepGram Nova 3, does this in under 150 milliseconds. That's faster than when a human blink. It supports 36 languages, handles background noise, and can even tell multiple speakers apart. Top providers in this space: DeepGram, Assembly AI, OpenAI Whisper, and Gladia. Each optimized for different use cases varying from medical transcription to multilingual call centers. Once your words are converted to text, they hit the second system, the LLM. This is the brain, and this is where the real intelligence lives. The LLM does three things simultaneously. First, it understands. It figures out what you actually mean, not just what you said. It tracks context across the full conversation, handles ambiguity, and maintains memory of everything discussed. Secondly, it reasons. It can call external tools, pull data from APIs, retrieve knowledge using RAG, and handle complex multi-step logic. This is how voice agents book appointments, check inventory, or pull up your account details in real time. Thirdly, it decides. It picks the best response, controls the tone, and starts streaming tokens immediately rather than waiting to finish the full answer. Now, speed matters massively here. Grok-served Llama can return a first token in 200 milliseconds. GPT-4o Mini at around 400. Claude Sonnet at 800. For voice AI, you will need the fastest model that still gives you the quality you need. The third system is text-to-speech, TTS. This is the AI's voice. And honestly, this layer has had the most dramatic improvement in recent years. 2 years ago, TTS engines took 2 to 3 seconds to synthesize audio. But today, Cartesia Sonic delivers first audio in 40 milliseconds. 11 Labs Flash at 75 milliseconds. DeepGram Aura 2 at 150. But it's not just speed. Modern TTS models are genuinely expressive. They add natural pauses, breathing, hesitation, vocal emphasis, all the things that make a voice feel human rather than robotic. You can control tone, warmth, assertiveness, even emotion through natural language prompts. And with voice cloning, you can replicate a specific voice with just a few seconds of audio across 100 languages. This layer is no longer a bottleneck. It's actually a strength. But the real challenge now is how everything is held together. Here's where most voice AI products fall apart. And it's not the individual systems, it's connecting them. Think about this. STT takes around 200 milliseconds, the LLM another 500, TTS another 150. Add network overhead and processing, and you're already at 1 full second. And humans expect a response in under 230 milliseconds for conversation to feel natural. That gap, that's the problem. There are 3 specific failure points. Let's begin with latency. Every millisecond delay matters. The best pipelines today achieve around 510 milliseconds end-to-end, which is still more than double human conversational speed. Secondly, sync. These 3 systems run on separate servers. Partial results need to stream between them in real time. Network jitter, token buffering, dropped packets, any of these causes audio glitches or awkward silences. Building this in-house takes engineering teams 6 to 12 months. Finally, the interruptions. What happens when you start talking while the AI is still mid-sentence? Most basic systems just ignore you. That's infuriating. Advanced systems need to detect that, stop the audio, discard the remaining tokens, and restart in real time. Even OpenAI's real-time API still has challenges here. So what separates a voice AI that feels robotic from one that feels genuinely human? It comes down to 6 specific engineering decisions. Number 1 is streaming responses. Instead of waiting for the LLM to finish generating the full answer, tokens flow directly to TTS as they're produced. This alone cuts perceived latency by 40 to 60%. Tools like PipeCat, LiveKit, and Daily are built specifically to orchestrate this. Number 2 is smart turn detection. The AI needs to know when you've actually finished speaking, not just when there's a pause. New models like DeepGram Flux do this in 260 milliseconds without needing a separate detection system. Number 3 is barge-in handling. If you interrupt, the AI stops instantly, discards what it was saying, and reroutes with no awkward overlap. Next is context memory. The AI maintains the full conversation across multiple turns, using summarization techniques to handle long sessions without running out of memory. Number 5 is emotional prosody. Breathing, hesitation, dynamic pitch, all controlled by the TTS model to make responses feel alive. And number 6 is speculative execution. The system starts generating a response based on partial transcription before you've even finished speaking. If the prediction doesn't match what you actually said, it discards it. If it does, you've just saved hundreds of milliseconds. All right, let's bring it all together with a real example. You say, "Book me a table for 2 tonight at 8 p.m. At 0 milliseconds, your microphone captures the audio. WebRTC starts streaming it instantly. At 50 milliseconds, STT has already produced a partial transcript. Book me a table." That gets sent to the LLM immediately, without waiting for you to finish. At 200 milliseconds, the LLM has decoded your intent. Restaurant booking, 2 people, 8 p.m. It starts generating a response. At 320 milliseconds, the first tokens are already flowing to the TTS engine. The LLM hasn't even finished its full response yet. At 410 milliseconds, TTS begins playing audio. You start hearing, "Sure," checking available tables, and at 510 milliseconds, the full response is playing, while API calls to the restaurant system are running in parallel in the background, under 800 milliseconds. Start to finish, that's the pipeline. This is what great voice AI looks like. Streaming, parallel, interrupt-aware, and human feeling. Not magic, but engineering. If you want to build systems like this or understand the tools powering them, that's exactly what we cover at SuperU. Drop a comment, subscribe, and we'll see you in the next one.